Welcome to our Electrical Engineering YouTube channel. In this video, we will see an example on equivalent resistance. To download our Electrical Engineering app, you can visit this website link electrical-engineering.app. This app is specially designed for electrical and electronics engineering students. Question: find equivalent resistance between terminals A and B. Now here for this network, we have to determine its equivalent resistance between terminal A and B. Solution: first of all, we will take this network. Now here we can see from here to here, this forms basically a Wheatstone bridge. Here we can see this is basically a Wheatstone bridge. Now this is a balanced Wheatstone bridge. So in case of balanced Wheatstone bridge, what will happen? No current will flow through this resistance. That means we can remove this resistance. So let's remove this resistance and then simplify the network. So when we remove this resistance, then this network will become very easy to solve. Now this R and this R, they are connected in series. So basically this will be simply 2R. And here also these two resistances are connected in series. So this will become 2R. So here also this will become 2R simply. Now this 2R and this R, they are all connected in parallel. So let's simplify this. It will be simply 1 upon RAB is equal to 1 upon 2R plus 1 upon 2R plus 1 upon R. So what will happen? 1 upon RAB is equal to, now this will be simply 1 by 2R plus 1 by 2R. This will be 2 divided by 2R plus 1 upon R. Here the denominator is same. So this 2 and this 2 will get cancelled. So what's remain? 1 upon R plus 1 upon R is equal to 1 upon RAB. So if we simplify this, so 1 upon RAB is equal to 2 divided by R. So therefore RAB is equal to R upon 2. So this is the final answer for this question, and this is how we can solve these types of problems. Don't forget to like, share and subscribe to this channel, and thanks for watching.